Hi, ladies. Today is May 18th, and we are on page 48 for our CGI lesson today. So take a look at the question in front of you. So today we're talking about a garbage truck, and it weighs a certain amount, and then it dumps some garbage out, and now it weighs another amount, and we want to know what the weight of the garbage is. So a full garbage truck weighed 10 and 6/10 tons. After dumping the garbage, the truck weighed 3 and 2/3 tons. What was the weight of the garbage? So a full garbage truck weighed 10 and 6/10 tons. After dumping the garbage, the truck weighed 3 and 2/3 tons. What was the weight of the garbage? So we have a truck that weighs 10 and 6/10 tons, and that's the truck that's full. So then our garbage truck is going to dump the garbage. So after dumping the garbage, the truck weighs 3 and 2/3 tons. What was the weight of the garbage? So our question that we're trying to solve today is what was the weight of the garbage? All right, so I want you to ask yourself, what do we know and what do we still need to know? So we've got this garbage truck. It's full of garbage and it weighs 10 and 6/10 tons. We're going to get rid of some garbage, okay? So we're dumping it out and now our truck weighs a lighter amount. And we want to know what the weight of the garbage was. So basically, if you think we have our truck here, we have some garbage that's now been dumped here, and now here's our new truck. So I want you to think, if this is our truck to begin with, we dump all this out and now we only weigh this much, are we going to be increasing this amount or decreasing this amount? And if we're increasing it, what operations does that tell me to do? And if we're decreasing it, what operations does it tell me to do? All right, so at this point, I want you to go ahead and make sure that you're doing your plan solve check. Pause your video, and then when you're ready, we will check it together. Hi, ladies. All right, so today is May 18th. You should have already solved the problem about the garbage truck. So now we're going to check our work together. So thinking about our problem, we have a garbage truck that weighs 10 and 6/10 pounds, or I'm sorry, tons. And then we take this amount. We're going to be dumping some trash on to like a dump, whatever. And then your truck's going to weigh this much. So we're going to be then weighing 3 and 2/3 tons. So we want to know, how do we get from here to here? So this is our truck before we dump the trash. This is our truck after we dump the trash. We want to know how much the trash weighed. So this is our hole, all right? So we know that we have a hole of 10 and 6/10 tons. And then we also know that when we, after we dump the trash, which we don't know how much that weighed, we have 3 and 2/3 ton left over. So thinking about if we already have our hole, what operation should we be using? Because we're going from a larger quantity to a smaller quantity, we know we either are going to use subtraction or division. But are we taking this amount and making equal parts, or are we finding the difference between what we know and what we have and then what we have now? So we're finding the difference. So we know we're going to be subtracting to find that missing quantity. So we're going to be taking our 10 and 6/10, and we're going to be subtracting it by 3 and 2/3. Remember, it's really important to stack these because it's a lot easier to work with them when they're stacked. Just a reminder, when we are subtracting or adding fractions, you want to make sure that you have a common denominator. You're going to bring over that whole number because your whole number is going to stay the same. Now we want to figure out, can our smaller denominator go equally into our larger denominator? So can 3 equally go into 10? No. So we want to think, what do these two numbers have in common? So Best thing to do is to think we have 10. We know 3 cannot go into 10. The next multiple would be 20. 3 cannot equally go into 20. Next would be 30. 3 can equally go into 30. So our denominator for these is going to be 30. I like to start with the larger of our denominators because your multiples are going to be bigger, because we know that 10 can't go into 3, 6, or 9 because they're less than 10 already. So if you count by your larger multiples, it makes it a little bit quicker. 10 times 3 is 30, so 6 times 3 is 18. 3 times 10 is 30, 2 times 10 is 20. So you'll notice that we have 10 and 18 30ths, and we're subtracting away 3 and 20 30ths. So you're starting right here with that 18 and that 20, and we know that we can't do that. So what we're going to have to do is borrow. So we're going to borrow from this 10 and make it a 9. And then in order to bring a whole over here, we're going to actually add together the 30 and the 18, which is going to give me 48. Because 30 plus 18 is 48. So now we're going to just subtract like normal. 48 minus 20, so 8 minus 0 gives me 8. 4 minus 2 is 2. And then my denominator is going to be 30. Now we're going to take 9 minus 3, which gives me 6. But what's really important about this type of a problem is you want to look at your fraction now and see if you can make it smaller or simplify it. Because 28 and 30 are both even numbers, I know that I automatically can divide by 2 to make those smaller. So I'm going to bring my, my whole number over. 28 divided by 2, so 2 divided by 8 is going to give me 4, or 8 divided by 2. And then 2 divided by 2 is 1. And then 30 cut in half is going to be 15. And I know that I can't make this any smaller because these two numbers are right next to each other. So my answer is 6 and 14/15. So what I can do to check my work on this one to make sure that this plus this equals this, I can actually take these numbers and I can add them together to see if it equals this. So 28 plus 20 is going to be 48. 6 plus 3 gives me 9, so I know that I'm correct. So the amount of trash that they dumped out is going to be 6 and 14/15 tons. And then my number sentence is going to be 10 and 6/10 minus 3 and 2/3, and that's going to give me 6 and 14/15. Remember, you can use the actual numbers because that is what represents your problem. And these are the actual numbers that are in the problem. But obviously, you had to find a common denominator to find your answer. But this is the problem that represents your work.